Hello there guys and welcome back to another epic Inexorable maths video. In this video we're taking a look at the discriminant. What on earth is it? Who came up with that name? What's going on, guys? Let's talk about it. Okay, so in simple terms, the discriminant is b squared minus 4ac, okay? It says it here, for y equals ax squared plus bx plus c, the discriminant is b squared minus 4ac, okay? And I've also written, this can be seen in the quadratic formula. So the discriminant is basically the part of the quadratic formula that is inside the square root. It does not include the square root, it's just b squared minus 4ac. It's the stuff inside the square root. That's actually really important because that will change the answers and that will change how things are calculated because we don't want to be taking the square root of this thing. Now, what is it? What does it do? We're going to get to it, okay? So b squared minus 4ac is the discriminant. If it asks you to calculate the discriminant, like a question that I've written here, calculate the discriminant for f of x equals x squared plus 8x plus 3, that means this right here is in the form y equals ax squared plus bx plus c. Just a note, you can basically use y and f of x interchangeably. They basically mean the same thing. Just for now, we're going to go with it. If you see an f of x, think of it as a y, okay? So f of x, that's just sort of there to throw you off a little bit, guys. So f of x equals x squared plus 8x plus 3. To do this, you would say a is 1, b is 8, c is 3. Let's plug those things into b squared minus 4ac. That would give you the value of the discriminant. Now, I need to tell you guys, what is it? The discriminant is a very, very, very valuable piece of information. It's a tool that you can use to decide, to calculate how many roots a quadratic equation will have. Recall that roots is the number of solutions to the quadratic when y is 0. In other words, the number of solutions to the equation ax squared plus bx plus c equals 0, where you will be told what a, b and c are. It's the number of solutions to that problem. The number of, the number of values for x that will satisfy that equation, okay? Why does it do that? Why does the discriminant tell you that? You might think, well, it doesn't really, I mean, it's just part of the quadratic formula. It doesn't really do any, like, it's just there. It's just sort of in there. This is the important bit. Observe the plus or minus in the quadratic formula. Now, plus or minus means plus or minus, which means if this thing here inside the square root, if it has a value that is anything except 0, any positive value, plussing or minusing it will give you different things. But if this thing here, this b squared minus 4ac, if b squared minus 4ac is 0, you're doing plus or minus 0. If you do plus or minus 0, what does that do? Nothing. So plussing or minus 0 does not change anything, and it doesn't give you two different answers. Plussing or minus 0 will mean that your x value will just be one x value. It will not be 2, okay? There's another case. What if b squared minus 4ac is negative? If b squared minus 4ac is negative, we run into a problem in maths. You cannot take the square root of a negative number in A-level maths. You can, but in A-level maths, you cannot do it. It doesn't make sense. Think about it. What does taking the square root mean? What does it do? To take the square root of something is to basically ask the question, what number multiplies by itself to make what is inside the square root? So for instance, the square root of 25, the value of this is the number that multiplies by itself to make what's inside the square root, which is 25. Now what number, or I should say two numbers, multiply together by themselves to make 25? The answer is positive and negative 5. So you could say the square root of 25 is plus or minus 5, okay? Or in another way, plus or minus 5 squares to make 25. Okay, that makes sense. Now, there's a problem, guys. There's a problem. Let's say we don't want the square root of 25. Let's say we want something like, let's keep it simple, the square root of minus 1. Okay, we're looking for the number that multiplies by itself to make minus 1. But hold on. Any time you times a number by itself, it becomes positive. Because two positives, as you know, multiply to make another positive number. But two negatives also multiply by themselves to make a positive. Which means there does not exist a real number that multiplies by itself to yield a negative number. So this, we say, is not real. Now, in A-level further maths and in various other courses, you might actually delve into that, but in A-level maths, we do not. We just say it's not defined, okay? So that's all you need to know. So I've written over here a few things. If the discriminant, b squared minus 4ac, is greater than 0, you will get two solutions to your quadratic equation, because plussing or minusing a non-zero value will indeed result in two answers, right? Let's say again it's the square root of 25. Let's say the discriminant is 25. Well, you do plus or minus the square root of 25. So instead of square root of 25, we'll just say the number 5. You're doing plus or minus 5, for instance. But hold on, adding 5 and also taking 5 away will give you different things. So you will indeed have two answers for x. But adding 0, if b squared minus 4ac was 0, and taking it away will do the same thing. So you're going to get one solution if b squared minus 4ac is 0. If b squared minus 4ac is less than 0, you will not have any solutions. X would not be defined in what we would say the real numbers. So I've just offloaded a lot of information at you guys. I hope you caught it. If you didn't, please let me know, give me some feedback. But we're going to just attempt this problem. We're going to do some simple plugging into the formula. I hope I've effectively and substantially explained why this discriminant nonsense happens. It's because of the square root. It's because of the plus or minus. Funny things happen with both of those, that's it. We're just going to use the formula now. This should be the easier half of the video. Okay, what's A? In x squared plus 8x plus 3, what's A? Well, A is 1, B is 8, and C is 3. What's the discriminant? The discriminant always is b squared minus 4ac, which means b squared, that's going to be 64. So I'm going to, sometimes, by the way, guys, just a notation thing, some people use a triangle, also known as a delta, to indicate the discriminant. So if you want, totally valid in exams, you can say delta equals b squared minus 4ac. I can even write that here. That just is a way to abbreviate the discriminant instead of having to write the discriminant every time. So the discriminant, which is signified by this letter, this is a Greek letter delta, also looks like a triangle, is going to be b squared minus 4ac, which is going to be 8 squared, which is 64, of course, minus 4 times a, which is 1, times c, which is 3, which is 64 minus, well, 4 times 1 times 3 is 12, which is 52. That means the discriminant is equal to 52, okay? So that would be your answer, okay? Now, tell me, you think about this, pause it if you need to, I want you guys to work this one out. Given that the discriminant is 52, how many, without working it out, without actually factorising, how many solutions will there be to this quadratic equation? How many roots will you have? How many times will this graph, remember in the previous two videos we were talking about graphs, how many times will this graph cross the x-axis? Think about it, and I'm going to tell you in a second, you'll pause it if you need to. The answer is 2, because the discriminant, which is 52, is clearly greater than 0, so we will have two solutions. So I'm just going to rub some stuff off the board and I'm going to sketch this graph to show you. Okay guys, so I've sketched the graph. As you can see here, this is what it looks like. Again, messy, Didn't use a ruler. If you were to do this in an actual exam, use a ruler, obviously. I haven't done it. I've just drawn a very, very poorly drawn parabola, quadratic function here. And this is, of course, the graph y equals x squared plus 8x plus 3. We know that the discriminant is 52 because we just worked it out. That's b squared minus 4ac. And we have got this. A lot going on here. Now, as always, oh, sorry, I've written c instead of 3. Silly me. Okay, as always, the c value is the y-intercept. So the point here is 0, 3. That's on the y-axis, has point 0, 3. Now, I just used the quadratic formula to work out these solutions because they're funny numbers. You can't really do this very well with other methods. Just use the quadratic formula. I got minus 4 minus root 13 as one of the solutions to this problem when it's equal to 0. And minus 4 plus root 13, okay? Which checks out, it looks good to me. And you can clearly see, just by drawing it, there is one solution there, that is one solution, and another solution there. So because this is positive, doesn't matter how big the number is, the difference between a number being 1, 52, and a million, the discriminant doesn't care. It doesn't really matter. It's still, if it's positive, it's going to have two solutions. There you are, 1 and 2. Let's do another one where we've got one solution. Okay guys, so we've got another question here. This is f of x equals x squared minus 8x plus 16. We want the discriminant. Remember, delta or a triangle means the discriminant in shorthand. In an exam, they will say the discriminant. They won't use this, but it's nice to write it. Everyone will know what you mean when you write it. Just helps me when I'm teaching. So we're going to use the discriminant formula, b squared minus 4ac. Looks beautiful. Pretty hard to forget because it's inside the quadratic formula. And we're just going to plug some things in. So a is 1, right? What's b, guys? I'll give you a second to think about that. And c is 16, yeah? b minus 8, okay? Trips people up every time. Negative in front. You have to include it as always. b is minus 8. Now, b squared minus 4ac. b squared. 64, yeah? So delta equals 64 because minus 8 squared is positive 64. Minus 4 times 1 times 16. So the discriminant is 64. 4 times 1 times 16 is 64. So it's 64 minus 64, which is 0. Which means the discriminant is 0. Now tell me, guys, if the discriminant is 0, do we have two solutions, one solution, or 0 solutions? We have one solution because b squared minus 4ac is 0, means one solution. Because this whole thing is 0, so your x value is going to be minus b plus or minus 0 over 2a. Plus or minus 0, that's just going to be one number, so you're going to have one solution. Okay, so again, I'm going to draw this very quickly for you guys. Okay guys, so I've just drawn it. I have labelled this graph y equals f of x, which just means y equals x squared minus 8x plus 16 because f of x is already being defined as x squared minus 8x plus 16. So it's very frequent. Oh, just dropped a pen lid there. It's very frequent that you will see graphs labelled y equals f of x. Do not be afraid. It just means that's f of x. F of x is normally told to you in the question. So one root, 1, which means it just, remember in a few videos ago, it just tangentially tickles the x-axis. Doesn't go through it, just touches it, skims it once, okay? Which makes sense because the discriminant, remember, in this question, is 0. Which means, yes, you were just going to have one solution at 0. As always, the graph goes through c, which is 16, and it's a happy face because the coefficient in front of the x squared is a positive number, okay? Now let's just do one more where the discriminant is a negative number. Okay guys, so we're just going to take a look at this question. I know the video is getting really long, but I hope you guys don't mind. I'm trying to do all of the discriminant in one video. Okay, so find the discriminant for this guy. Now, there's a few issues with this, isn't there? This is clearly in the wrong order because we want the x squared term to be at the front. We've got a bunch of negatives in there which don't look nice, and there's lots of things in here that are going to throw you off, or not necessarily going to throw you off, but they could throw some people off, and they might throw you off. So we want the discriminant. The discriminant is b squared minus 4ac. Let us very carefully figure out what A, B, and C are. We must be careful, okay? So I'm going to rewrite f of x in the correct order, where the A, or the x squared term is at the front. So this is the x squared term. I'm going to put it at the front. So it's minus 3x squared. Remember, the minus is going to have to come with it. Minus 3x squared. 2x is a positive 2x. That's the bx term. So we're going to add 2x. And the c is where it should be. It's at the end. Minus 4. That's the c, okay? Which means that a is minus 3. B is 2. And C is 4. Joking, minus 4. Pay attention. I'm just joking, guys. I know that you are. Okay, A is minus 3, B is 2, and C is minus 4. B squared minus 4AC, let's do it. B squared, that's 2 squared, which is 4. Actually, I need to write discriminant equals 4, that's the B squared, minus 4 times A is minus 3, times C is minus 4, and we're going to calculate what this is. So the discriminant is 4 minus, let's start, because this is a bit complicated, let's just do the 4 and the minus 3 first. 4 times minus 3 is minus 12, so it's going to be minus 12 times minus 4, because the minus 4 hasn't changed, which means the discriminant is equal to 4 minus, okay, minus 12 times minus 4 is the same thing as 12 times 4, because the two negatives cancel out, which is going to give us 48. So we're taking away positive 48, because that's positive 48, and the minus sign there still stays, which means if I can fit it in, 4 minus 48 is minus 44. So the discriminant is negative 44. And again, I'm going to draw this for you guys. Okay guys, I've just drawn this graph. It looks really silly, doesn't it? First thing to note, it's a sad face because A is minus 3. A is negative, and in the graphing couple of videos, we talked about what happens when A is negative. When A is negative, we have a sad face. So we're looking at a sad quadratic. The y-intercept is minus 4, which is clearly just a little bit below the y-axis, is 0, minus 4. This is the graph of y equals f of x, and it does not cross the x-axis. That's why it looks weird. It doesn't actually go through the x-axis from above, from below, from nowhere. It just doesn't go through there. And you might say, well, how does it not? Why does it not? Why is it doing this? The answer is because when you set this equal to 0, so that means 0 equals 2x minus 3x squared minus 4, you literally cannot get a number for x that will satisfy that equation that is a real number. Now there do exist complex numbers and imaginary numbers, but again, the A-level maths curriculum does not go into that. So you would say there are no real solutions, or you would say the value is undefined, I guess, because b squared minus 4ac, remember in this question, the discriminant is negative 44. It's negative, so there are 0 solutions, and a solution is where the graph crosses the x-axis. The graph clearly does not cross this line, which is the x-axis, so there are no solutions, okay? So guys, I hope that helped you. Really long video, I think it's my longest video so far, so I do apologise for making it too long, but I was trying to just get it all done in one video. Thank you guys so much for watching. If you enjoyed this video, please like, subscribe, tell your friends about the discriminant, but we do not discriminate, okay? The discriminant, we love it, no discrimination though. See you guys in the next video.